All right, Chapter 9. This chapter will deal with rational expressions. We told you in Chapter 8 that factoring is just one of the most important skills that you're going to learn in this class, and in this chapter you'll pretty much see why. For almost all of the problems in this particular chapter, the first step is usually going to be factor everything, so that if you don't know how to factor, you're really pretty much stuck. There's just nothing you can do with these problems.
Absolutely. So let's go ahead and get started. Going back to the days when you were, I don't know, maybe in middle school, elementary school, and you had fractions like this. This fraction, you could not leave it in those terms. You actually had to reduce that fraction. So before we get started with these problems, the much harder ones, we wanted to take you back and connect it to what you already knew. So in this first problem, 14/16, you looked at it and you said, hey, there is something common. If I broke this up into 2 times 7, and the denominator into 2 times 8, I could then cancel the 2's. Now I know this isn't the way everybody has done it in the past. Sometimes you write division, but for the sake of our problems, this is what we wanted to show you. When you have things that are multiplied together, you are allowed to cancel them. And that leads to your final answer of 7/8.
Right, let me just pick up on something Jerry said. When you probably do a problem like this in your head, you probably think, okay, 2 goes into 14 7 times and you write the 7, and 2 goes into 16 8 times and you write the 8. But what you're really doing is factoring 14 as 2 times 7 and factoring 16 as 2 times 8, and then since the 2 is common, you're canceling it. And seeing it done that way should connect pretty clearly to what we're about to do next. That's why we've taken the trouble to write it out that way.
Absolutely. So let's look at this next problem. We're going to assume that you're doing a lot better with your factoring now.
All right, so I'll go ahead and do this one. This one is a trinomial because there's 3 terms, so this is that type of factoring we're used to. And using Jerry's approach, I'm reading right to left, so I need numbers that multiply to 3 and add to 4. So I'll put in my x and my x, and 3 only has 2 factors, 1 and 3, so I know the numbers are 1 and 3. But I need them to add together to -4. So to get -4, I must need -1 added to -3. So x minus 1, x minus 3, it's factored.
That's it. In the denominator, rule 1, you see a lot of students think this is going to work out as a trinomial type problem with 2 parentheses, but when you look at it and you follow that first rule, you can take out an x. And what you have left, x minus 1 goes in the other parenthesis. Now we're just going to apply that same principle that you did way back in elementary school and didn't even know you did it. And that is the principle of cancellation right here. So we see an x minus 1, as long as you have an identical binomial in the denominator, x minus 1, you can cancel them. Now, this actually leads us to our final answer, x minus 3 over x. But Bill, I know you want to comment because some students keep going.
Right, so 2 things. First of all, again, you can cancel the x minus 1 in the top with the x minus 1 in the bottom because we're multiplying the 2 factors in the top and we're multiplying the 2 factors in the bottom. You can cancel things that are being multiplied together. In this step, you might be led to think, okay, there's an x in the top and there's an x in the bottom, so now I can cancel these. But unfortunately, you would be wrong. You can't cancel things that are being added and subtracted. You can only cancel something in the top with something in the bottom if you have factors, things being multiplied in the top, and factors, things being multiplied in the bottom. My shortcut way of talking about this in class is you can't cancel across plus and minus signs. You can't cancel things that are being added and subtracted. And really, it's one of the most common mistakes we'll see in this section. So if this is a mistake you've made in the past, and chances are a lot of you have, this is a good time to try to get out of that habit and not make that mistake anymore.
Absolutely. Let's look at another problem. Okay, this one. In the numerator, the first thing you should notice is a difference of 2 squares. 2 terms, they don't have anything in common, and you have that minus sign with a 16. So factoring that into x plus 4, x minus 4.
Again, the x times x is x squared, the 4 times 4 is 16, perfect squares.
Absolutely. Now, You know, I say absolutely too much, Bill.
We all do
You
that
just
when
always
we
have
teach.
right
We all say
answers.
the same thing over and over and over.
Okay, the denominator is a trinomial, and think about all those factors of 12, 1 and 12, 2 and 6, 3 and 4, and you want the ones that subtract to give you that 1 in the middle. Well, clearly that's going to be the 3 and the 4. So put in your x's, your 3 and your 4, and you want a negative 1, so make sure the 4 is negative and the 3 is positive. From here, you're almost there. Cancel out the x minus 4's, and since the other two binomials are not identical, you just rewrite this as your final answer.
Right, and again, you'll notice that we usually drop the parentheses in the final answer. That's typical, but if you leave the parentheses in your final answer, it's still correct. It doesn't really make any difference. It's worth mentioning that if you made a mistake in your factoring, so let's say instead of picking 4 and 3, you picked 2 and 6, you would then be in a situation where there was nothing in the top that cancels with anything in the bottom. These problems in this chapter pretty much have been rigged. If you do all of your factoring and there is no common factor in the top and the bottom, chances are that you made a mistake. There's got to be something that cancels in the top and the bottom, or frankly, they would not have given you the problem.
Unless your teacher was on something and obviously made a bad question.
Yes, unless your teacher made a mistake, or unless your teacher was trying to be particularly tricky. But I don't really know any teachers, I think, who do that. If they give you a problem where they want you to reduce it to lowest terms, it can be reduced.
That's correct.
Okay.
All right. The next question is a little bit more complicated, and I believe normally on exit test, Bill, this is a very common type of question. They like to give you the problem with coefficients at both ends. They don't give you one of the easier ones as we've looked at. Now, for the sake of this problem moving along a little faster, we're not going to go through all the steps required to factor it. Remember, this is the one where you take the 3 times 4, you get 12, and then write out all the factors of 12 and then use factoring by grouping. Bill and I, and I'm sure some of you are getting into the habit of just seeing these problems with their answers. In this one, I know that if I put a 4 and a 3 in this order, I'm going to end up with a positive, or in this case, I need a negative 7x in the middle.
Right, because we could check this using our little FOIL method. The outside term is negative 3x, the inside term is negative 4x, negative 3x and negative 4x is negative 7x. But again, if you're still taking a while to do a problem like this, just do that factoring separately off to the side, and once you have it factored, transfer your answer back to the top of the fraction. Don't worry about trying to do them as fast as Jerry and I do them. Remember, we've been doing this for a long, long, long time.
Too long, no.
Probably much too long.
Okay, the denominator, something should jump out at you. You see there are like terms here. You can take out an x squared, and what is remaining is 4 minus 3x. Then this brings you to a decision. You notice these two terms look very similar, except their signs are exactly opposite of what you want. When I say that these signs are opposite, you'll notice that on the 3x, it's positive here and negative down here, and on the 4, it's negative here and positive down here. When this situation happens, go back to that rule 1 that we've learned in factoring and say, okay, what if I factored out a negative 1 from this denominator's expression? Well, negative 1 times negative 4 would give me positive 4, and negative 1 times positive 3x would give me negative 3x. This can then be rewritten in the proper order, 3x minus 4, to match the 3x minus 4 in the numerator. So in essence, what we're telling you is when you see this situation, you can cancel these, but you just have to add a minus sign or a negative 1 somewhere. Bill, any comments on that?
No, I just, this is something it's pretty hard to recognize unless you've been trained. But rather than actually doing the factoring that Jerry showed in the bottom, it's worth just training yourself. If you see 3x minus 4 in the top and 4 minus 3x in the bottom, just cancel them, but instead of canceling them to 1, they cancel to -1. You can put the negative sign in the top or in the bottom. It doesn't really matter.
There you go. So our final answer, we're going to have x minus 1 in the numerator. If you want to put your minus off to the side for the -1, that's fine, or you can leave it down there in the denominator. So our final answer is negative x minus 1 over x squared, and that wraps up simplifying rational expressions.
That's right.
Okay, just like we did in the first section when we were simplifying rational expressions, we're going to take you back to your middle school or elementary school days and just remind you of when you were multiplying fractions, some of the procedures that you used to do this. The first step in this problem, some people might say, well, multiply across, which you can do. We're going to recommend a little different approach because we know where this is leading to. We're going to recommend that you cancel before you multiply. And to start out in this problem, you see 4 and 8 both have a common factor of 4. So 4 goes into 4 once, 4 goes into 8 twice. Then you look at the 3. Well, 3 and 9 are both divisible by 3. 3 goes into 3 once, 3 goes into 9 3 times. Now multiply what you have remaining. The numerator you have 2, denominator 3. So this problem simplifies to 2/3. Okay? Our next question is obviously where we're leading to. Now, the first step, just like it was in the previous section, is to factor everything that you can before you do any canceling. Because remember, you can't cancel x squares and x squares because they're being added or subtracted. So, our numerator is a difference of 2 squares. You might say, how did I recognize that? Remember, 2 terms with the minus sign and a perfect square. So that factors into x and x, 1 and 1, plus and a minus. The denominator, there's only one set of factors of 5, so I won't write them out. The factors of 5 that add to give you 6 are 1 and 5.
And remember, if the signs are all plus in the problem, that means all the signs in your factoring are plus too.
Absolutely. So on this problem, the denominator factors into plus 1 and plus 5. On the right side, the numerator is again very similar to the numerator we had on the left side. It is another difference of 2 squares. The quicker you recognize them, the quicker you can get through these problems. Put your 5s and your x's, plus and a minus, and the top, the numerator here is finished. Then the denominator, the only thing you can do with the denominator here is take out an x squared, that infamous rule 1, and it leaves you with x minus 1. So, looking at this, now it's time, this is always the fun part, to go cancel everything. Start with the x minus 1s. Those cancel out. Then you'll see an x plus 5. Those cancel out, and then the x plus 1.
It's worth mentioning, some of you seem to believe you can't cancel things unless they're diagonally across from each other. You're not supposed to cancel if they're top and bottom, and that's simply not true. Anything in the top can be canceled with anything in the bottom. It doesn't matter whether it's on the top in the right side or on the top in the left side. I mention that just because I've had students ask me about that, so I get the impression that some students have gotten that feeling from something teachers taught them before.
That is a good point.
So let's see what's left over.
In the numerator, we have an x minus 5 and the denominator x squared. And one thing Bill and I can both agree on, if you are not neat when you are doing this, and some of you will have this tendency, and I will add this in the picture, to draw your scratch outs and leave them go, or let them go a little bit longer than they should, you will cross out things you didn't mean to cross out, and you'll end up with totally different answers.
That's right. So do be careful with your penmanship in these problems. It's very easy to have a loose mark give you a wrong answer. Every loose mark could be a negative sign.
Good point. Okay, let's look at the next one. All right, in our numerator, we see on the left side, this numerator cannot be factored at all. So you just rewrite it. You like those problems. The denominator is another one that would require for some of you to multiply 2 and 3, write out all the factors of 6, and then use factoring by grouping.
Again, we're just going to go directly to the answer because, as we've mentioned, Jared and I have been doing this for quite a while.
That's right. So on this one, since I know I only have two factors of 2, I can put the 2, and that's like 1 right there. And for my 3, my factors of 3 here and here, because I know I want to subtract to get a 1 in the middle. So if I put a plus on the 3 and the minus on the 1, that, trust us, does factor. All right. Numerator over here, another difference of 2 squares.
Yeah, those problems pop up all the time, so if you're not used to seeing them before, you'll be used to seeing them by the end of this chapter.
Absolutely. So put in our 3's, our 2x's, a plus and a minus, and that numerator is now factored. In the denominator, just a rule 1. Take out the 3, what you're left with, x minus 2, and it is now factored. And again, the fun part. Canceling away. Well, this x minus 2 can cancel with that x minus 2. I almost did one of those mistakes. Then here the 2x plus 3 can cancel with that 2x plus 3. And that's it. Our final answer, we have 2x minus 3 in the numerator. In our denominator, we will leave the parentheses on because we have that 3. And we don't, it is not required in most courses. Your teacher may disagree with us. But you do not have to multiply these back out. Leave them as they are.
Right. As a general rule, once you've factored, leave everything factored. Nobody expects you to multiply it out, I don't think.
No, because some of them get pretty nasty.
Yeah, yeah.
Okay, and that one's finished. The next part, division. Some of you might recall, again, the difference between multiplication and division of fractions. Simply one different step or one simple procedure change. If you recall, division is simply multiplication rewritten. You take the reciprocal of the term that follows the division symbol, and the reciprocal means you switch the numerator and the denominator. Now it's a multiplication problem. Now we're doing exactly what we were just doing with the last ones. That is, cancel first, multiply across second, final answer, 1/3.
All right, and so now we'll look at some division problems featuring rational expressions. And again, once you've rewritten them as multiplication problems, these are pretty similar to the problems that we just did. There's really not much new here. It's rewrite it as multiplication, factor, cancel, and then just see what's left over.
Now, Bill, I know sometimes some teachers tell you to rewrite the whole problem first. Others say go ahead and factor from the beginning. Obviously, we don't care. If we knew you personally, we would probably tell you which one's going to work best, but we don't. So we're just going to go ahead and complete this one the long way. And that is step 1, rewrite it by taking the reciprocal of this right-hand side. Now we're going to factor. Numerator on the left is another difference of 2 squares. 3 plus x, 3 minus x. Denominator, can't do anything with. Numerator on the right side, I can take out an x squared, and that leaves me with x minus 5. That's the rule 1. And then the denominator, you might need to write out your factors of 15 real quick.
Right, we'll need to find the factors of 15 that add to 8.
That's it, and you know that has to be the 3 and the 5. So, writing this out. Whoops, before I put in those signs. We are adding, and when we're adding and the middle term is negative, both signs will be negative.
That's right. Again, when the last line's plus, the signs are the same. So to get negative 8, I would have to add negative 3, negative 5, and now it's time to cancel.
Time to cancel. Okay, we see the x minus 5s. They're gone. We see that 3 minus x and x minus 3 situation, and look closely. Again, 3's positive, here it's negative. Here the x is negative, here it's positive. So when that situation occurs, cross it out and add a negative somewhere. That's a negative 1. The last thing, we haven't had this happen yet, is our monomials out in front can be canceled. Now, if you recall from the previous chapter when we covered exponential laws, When you divide, you actually just subtract the powers, and 3 minus this 2 up here is going to leave you with a power of 1, or just x. So our final answer, we have that negative, carry it over, put it in front of 3 plus x, don't just attach it to the 3, and then the denominator is x, and that is your final answer. Okay, back to adding and subtracting rational expressions with common denominators. Just like we've done in the first 2 sections of this chapter, we're going to take you back in time to your middle school and elementary school days. When you're adding fractions, just remember, it is always the denominators that you need to be alike, and when they are, you only add the numerators. So in this situation, you carry the 2 over, and then 3 plus 5 is 8. Then, if possible, you can reduce this. And in this situation, we know that 8 divided by 2 is 4, so that is our final answer. But this principle is exactly what we're using with all the problems that follow.
That's right.
The second problem here is more what you're going to see in your textbook. Again, you notice the denominators are the same, and in this chapter, they're always going to be the same, which is nice. We'll save the hard ones for intermediate algebra. Rewrite your denominator and then say, okay, can 3x and 2x be added together? The answer is yes. You get 5x, and then you look at that and say, can I reduce this? Bill, can we reduce that?
Sure, there's a 5 in the top and a 5 in the bottom. They're being multiplied. They're identical, so you can cancel them.
That's it. Just cancel the 5s. Your final answer is x. Now, obviously these problems get a little bit more complicated. Let's look at this. And good news is we don't have to worry about factoring right now, do we?
That's right.
Not in the beginning.
We won't need to factor for these problems until the very end, at least for now.
That's right. So denominators are the same, so carry the x minus 1 over. And now look at your numerator. Remember like terms. The numerator here, we only have 1x squared term. Then you see the x's. You have a 3x and a 2x, and that gives you 5x. And lastly, you carry over that minus 6. Well, you have a binomial denominator, a trinomial numerator. You see those, you see the 6, and you ask yourself, are there factors of 6 that subtract to give me 5? Hopefully at this point you say, yes, there are. 6 and 1.
And we need them to subtract a positive 5, so that means we would need positive 6 with negative 1. Again, like the problems that we dealt with beforehand, these problems are rigged. So if something can be factored, you should go ahead and factor. Chances are it's going to cancel with something in the bottom, or they wouldn't have given you a problem where something factors.
That's a great point. See, we really aren't that smart. We just learned all the tricks of our
That's
teachers.
Right, that's right.
Okay, our final answer here, once you cancel out the x minus 1s, leaves you with just x plus 6. And that's your final answer. The next question, we have our first subtraction. And subtraction, we have to be very careful, don't we? In the top, the first thing you want to see is this situation. I know Bill covered this back in that first or second chapter.
Yeah, but it's been a long time. It's probably worth talking about again.
Yes, when you subtract, and this is subtraction of a binomial, it's just like taking a negative 1 and distributing it out across that binomial. So I'm going to basically take 2 steps here. I'm going to put my 7 down here, but instead of combining all my like terms at this point, we're going to rewrite the numerator without the minus sign. The first part is 3x minus 4. The second part, negative 1 times 2x, is negative 2x, and negative 1 times negative 3, positive 3. Okay, now you've addressed the minus. The most common mistake is students put the minus on the 2. They could care less about the minus 3, and of course, that's probably the type of question they'll see on their final exam. So our final answer, we have 3x, and a negative 2x is just x. Negative 4 plus 3 is negative 1 over the 7.
Right, and there's nothing really to factor there, and there are no common terms, so we can't cancel. That's just the answer.
That's it. Okay, the last one, we decided to make this one just a little bit more uglier.
Challenging,
Probably a
yeah.
politically incorrect word to use there, but
But this is probably about as hard as these problems will be, at least in our course. So if you can do this problem, you should be pretty confident that you understand this at a really pretty deep level.
absolutely. So we start with the first step. Remember, I want to put a -1 here because I want you to be thinking about distributing that -1 across both those terms. So just like we did last time, rewrite the denominator and then carry everything over in the numerator, not the denumerator. Never heard of that one before. So we end up with a -x and a -3. Okay, and then combining like terms, we only have one x squared term, and then we have a 5x and a -x. It's going to give us 4x, and then a -3. Bill, do you think we're finished?
No, again, if you get this far, since the top looks like it might be able to be factored, and the bottom by now certainly looks like something can be factored, you should definitely factor this. Chances are something's going to cancel.
Yeah, chances are, especially since I've created this problem,
That's
I
right.
can tell you something's going to cancel.
Again, we're going to go directly just to the factorization of the top, but if you want, you can just do that problem separately off to the side, go ahead and factor it, and just bring your answer back and put it in the top.
Good point. Now, in the numerator, this factors into 2x, 3 and 1, and we're going to end up with a +4. So I know that's how the numerator is going to factor.
Right, we need positive 6x, the outside term, plus negative 2x, the inside term, to add to positive 4x.
That's right. And our denominator is simply a difference of two squares. Put your 2x, +1, -1, and then voila, you see the point of the whole question, which was we are going to have something to cancel at the end, which are the 2x minus 1s. So your final answer in this problem, 2x plus 3 over 2x plus 1.
And at the risk of saying this over and over and over, no, you can't cancel the two x's in the top and the bottom because they're being added and subtracted. They're not being multiplied together.
Absolutely. Well, Bill, I think that wraps up this chapter.
All right. Oh, no, we still have proportions, actually. This wraps up this section. So this wraps up the section. This takes care of addition, subtraction, multiplication, division of rational expressions. Now let's move on and talk about proportions.
Okay, at the end of chapter 9, we bring in proportions, and the reason why we bring in proportions at this point is because it is probably the #1 application of rational expressions.
Right, and these are also problems that do appear on the exit test. So in this particular chapter, we're going to talk about how to set up these problems, and then in the next chapter, we'll talk about how to actually solve them.
Absolutely. So this first problem, reading it, if a car uses 15 gallons of gas to travel 400 miles, then how many miles can the car travel on 20 gallons of gas?
Just go ahead and fix it, Jerry. Don't worry about it. So that should be then.
Okay, so when we set this up, set up your first fraction, and you may put 15 over 400 or 400 over 15. But what I like to do is add the units. Gallons of gas, 15 represents gallons, 400 represents miles. And we set up an equal sign. Because I put gallons over miles on the left, I need to put gallons over miles on the right.
That's right. The key principle here is whatever you put in the top has to be on the top in both sides, and whatever you put in the bottom has to be on the bottom in both sides. You can put miles in the top or gallons, but if miles is in the top on one side, it's got to be in the top on the other side too.
That's it. So we have 20 gallons. Our question is then how many miles can the car travel on 20 gallons of gas? Well, 20 G's for gallons in the numerator, and then since we don't know how many miles, we put an X for miles. And for this chapter, that's all you're doing, just setting them up.
Right, so we now know that to solve this problem, we would have to solve the equation 15 over 400 equals 20 over X, and we'll talk about how to do that in the next chapter.
Absolutely. Now, one last thing, you can erase these or remove them. Your final answer to this problem when you set it up is simply this right here, 15 over 400 equals 20 over x.
Right, we put the units down there to help you set up the problem. Once you got the problem set up, you don't need the units anymore. You can either rewrite the problem or you can just erase the units.
Okay. Okay, the next question, if 6 cans of corn cost $4.50, what would 9 cans of corn cost? Again, however we decide to set it up on the left will determine our right-hand side. So we know that 6, and I'll put little c for cans of corn, is to 450 as, and over here, we know we have 9 cans cost x. And I'll put the dollars next to it. And again, remember, now this one, if you want to leave dollars, you can, but typically your final answer, ignore those marks. That's how it would look when you set it up.
That's right. Finally, I think this is the last one, right?
I believe this is the last one. Okay, if it takes 6 people to build a pool in 1 month, then how many will it take to build 5 pools in 1 month? Okay, so on the left side, most students, if they're just like me, the first thing written is your numerator. So we have 6 people to build 1 pool. Now, since I have the P already used, I'll put double O for ool.
Okay.
All right. And then on the right-hand side, how many, since we don't know how many people, it'll take to build 5 pools in a month. And that's it. Again, ignore your little notes there, and this problem is now finished.
Right, and again, in the next chapter, we'll go ahead and talk about how to solve these in chapter 10. All right, I think that's it, isn't it, Jerry?
I believe that's it.
All right, let's quit. Maybe we'll get some ice cream or something.
Ice cream sounds much better than fried chicken.